We will now talk about three-point starter. A three-point starter, in simple words, is a device that helps in the starting and running of a shunt wound DC motor or compound wound DC motor. Now the question is why these types of DC motors require the assistance of the starter in the first case. The only explanation to that is given by the presence of back EMF EB, which plays a critical role in governing the operation of the motor. Actually, the back EMF is developed because the motor armature rotates inside the magnetic field. When it rotates because of generating action, that is movement of conductors in the magnetic field, there must be an induced EMF across the conductors, according to Faraday's laws of electromagnetic induction. Obviously, this induced EMF will oppose the supply voltage. Since this supply voltage is the ultimate cause of the rotation. This also essentially means that the back EMF at the starting is zero and develops gradually as the motor gathers speed. The general motor EMF equation should be E equals EB plus IA RA. As at starting back EMF is 0 EB equals 0, this equation can be written as E equals IA RA. Therefore, IA equals to E by RA. Thus, we can well understand from this equation that the current will be dangerously high at the starting, because we all know armature resistance RA is normally very small in all DC motors. That is why we use a device like the three-point starter to limit the starting current to an allowable lower value. Let us now look into the construction and working of three-point starter to understand how the starting current is restricted to the desired value. For that, let's consider the diagram as shown here. Here, all essential parts of the three-point starter are clearly shown. Construction-wise, a starter is nothing but a variable resistance. It is integrated into number of sections as shown in the figure. The contact points of these sections are called studs and are shown separately as off, 1, 2, 3, 4, 5, run. Other than that, there are three main points referred to as 1. L-line terminal. This terminal is connected to positive of supply. 2. A armature terminal. This terminal is connected to the armature winding. 3. F field terminal. This terminal is connected to the field winding. Because of these three terminals, it gets the name three-point starter. Now, studying the construction of three-point starter in further details reveals that the point L is connected to an electromagnet called overload release, or in short, OLR, as shown in the figure. The other end of OLR is connected to the lower end of the conducting lever of starter handle, where a spring is also attached with it, and the starter handle contains also a soft iron piece housed on it. This handle is free to move to the other side run against the force of the spring. This spring brings back the handle to its original off position under the influence of its own force. Another parallel path is derived from the stud 1, given to another electromagnet called no-volt coil, or NVC, which is further connected to terminal F. The starting resistance at starting is entirely in series with the armature, as you can see here. The OLR and NVC acts as the two protecting devices of the starter. To start with, the handle is in the off position, then the handle is slowly moved against the spring force to make a contact with stud number 1. At this point, field winding of the shunt or the compound motor gets supply through the parallel path provided to starting resistance through no voltage coil. While entire starting resistance comes in series with the armature. The high starting armature current thus gets limited, as the current equation at this stage becomes IA equals E by RA plus RST. As the handle is moved further, it goes on making contact with studs 2, 3, 4, etc., thus gradually cutting off the series resistance from the armature circuit as the motor gathers speed. Finally, when the starter handle is in run position, the entire starting resistance is eliminated and the motor runs with normal speed. This is because back EMF is developed consequently with speed to counter the supply voltage and reduce the armature current. The handle is moved manually from off to the run position with development of speed. Now the obvious question is, once the handle is taken to the run position, how is it supposed to stay there as long as the motor is running? To find the answer to this question, let us look into the working of no voltage coil. The supply to the field winding is derived through no voltage coil. So when field current flows, the NVC is magnetized. Now where the handle is in the run position, soft iron piece is connected to the handle and gets attracted by the magnetic force produced by NVC because of flow of current through it. The NVC is designed in such a way that it holds the handle in run position against the force of the spring as long as supply is given to the motor. Thus NVC holds the handle in the run position and hence is also called hold-on coil. Now when there is any kind of supply failure, the current flow through the NVC is affected and it immediately loses its magnetic property and is unable to keep the soft iron piece on the handle attracted. At this point, under the action of the spring force, the handle comes back to off position, opening the circuit and thus switching off the motor. Thus it also acts as a protective device, safeguarding the motor from any kind of abnormality. Hope you got a clear idea of 3-point starter. Thank you.